Let's look back at some skills that we looked at last lesson. So here we have the equation 3y take 4x equals 5. So this is a linear equation because I see my variables y and x are both to the power of 1. We're going to sketch this equation by finding the y and x intercepts. So recall the very important line here. The y-intercept is when x equals 0. So to find the y-intercept, I substitute in x is 0 and solve. And I get y equals 5/3 or 5/3. Now the x-intercept is when y equals 0. So again, I'm going to substitute into my equation y equals 0 and then once again solve, and I get x is minus 5/4. Okay, so here I've completed my sketch of the equation. I see my x-intercept at minus 5/4 and my y-intercept at 5/3. So remember here, when we're completing a sketch, I'm not marking off my axes. I'm just doing a rough to scale sketch of the straight line. I can see here though, I know the x-intercept and the y-intercept, but how do I figure out the gradient of this line? Well, I could draw a triangle here and calculate my rise divided by my run. However, there is another way. And here, I can figure out the gradient of this straight line if I rearrange the given equation into the form y equals mx plus c. So doing this, I'd add 4x to both sides. I like to put that first on the right hand side. So I see I've added 4x to the right hand side. Now divide each term by 3. So I need to divide my 4x by 3 and my 5 by 3. And I get the equation y equals 4/3x plus 5/3. When it's written like this, in the form y equals mx plus c, I can read my gradient straight from the equation as 4/3. So here, see that the gradient is the coefficient of the x term when it's written in the form y equals. Okay, so moving to the next concept, it is worth pointing out that when I found the y-intercept, that's when my straight line crosses the y-axis, which is also the line x equals 0. So if I draw in that line x equals 0, well then, in that first step, I actually solved a very lame simultaneous equation where my first equation was 3y minus 4x equals 5, and my second was the line x equals 0. And I see the solution to that simultaneous equation is that coordinate there, which is the coordinate x equals 0, y equals 5/3. So, the solution to a simultaneous equation is actually the intersection point of two straight lines. So what we'll do now is have a look at a couple of examples where we don't have this really boring second line. Let's consider the simultaneous equation y equals 2x minus 3 and y equals minus x plus 6. So in our last unit of work, at the start of the year, we solved simultaneous equations like this. However, we can produce a sketch and have a look at this graphically. So my first equation, y equals 2x minus 3, I've sketched that straight line. I see the y-intercept is minus 3, and I can read that directly from my equation. To solve for the x-intercept, that's when y equals 0, and I found the x-intercept was 3/2. So there's my first line. My second line, y equals minus x plus 6, I see the y-intercept is plus 6, straight from my equation. Then solving, the x-intercept is when y equals 0. I find that x also equals 6. So these lines, so this straight line here, is the collection of x, y points that satisfy this equation. Here, with the green line, this is the collection of xy points that satisfies my second equation. Well, note here there's only one point that lies on both lines. That is the intersection point, and that xy value satisfies both of these equations. So the solution to a simultaneous equation is given by the intersection point of two linear graphs. So how do we find this point? Well, we have two methods that we looked at earlier in the year, substitution or elimination. It's really important that you're familiar with both techniques because they will come up again and again and again. So here we're going to use substitution for this example. So here are my two equations. I see y in my second equation is equal to minus x plus 6. So what I'm going to do is take this expression that is equal to y and replace it in my first equation. So I get minus x plus 6 equals 2x minus 3. Now solving for x, I get x is 3. Now I need to substitute this solution back into one of my equations to find the value of y. Substituting back into 1, and I get y equals 3. So this means the lines y equals 2x minus 3 and y equals minus x plus 6 intersect at the xy point 3, 3. Let's look at one more example. Let's find the intersection point for y equals minus 2x minus 1 and 3y plus 6x equals 4. Okay, we'll do this algebraically first. So I'm going to use substitution again. I see that y is equal to minus 2x minus 1. So I'm going to write this expression for y in my second equation. So here's my 3 times what y is equal to, plus 6x equals 4. Now expanding here, I have minus 6x minus 3, minus 6x minus 3 plus 6x equals 4. Cancelling off my x's here, or collecting, I get 0x, and I'm left with minus 3 equals 4. Whoa, what does this mean? Well, that's not true. That's false. So something's gone wrong here. Let's have a look at Desmos, which is a really good tool to check your work. So here in Desmos, I've plotted those two lines. Y equals minus 2x minus 1. So there's my red line. And my second equation, 3y plus 6x equals 4, which is the blue line. So apart from the time in the top left, which shows I'm working out of hours here, what else do you notice about these two lines? Yes, they're parallel. So these two lines are never going to intersect, so there's no solution. So that's why when we did our working before, we got nonsense at the end. Okay, that's because there is no solution here. These two lines do not intersect. So parallel lines do not intersect. As long as we're talking about, of course, flat Euclidean geometry. However, if we're talking about curved space, like the Earth, well, parallel lines, different lines of longitude, indeed do intersect at the poles. In space, light rays that might be parallel, travelling near a black hole, might actually get bent due to the curvature of space-time and intersect. But definitely in our case, these two lines do not intersect. That's because they have the same gradient. So I see equation 1, the gradient is minus 2. So this second equation must also have a gradient of minus 2. So let's go through and check. If we want to establish the gradient of the second equation, we need to write it in the form y equals mx plus c. So my first step, I'll subtract 6x from both sides. So 3y equals minus 6x plus 4. Next I need to divide each term by 3. So y equals minus 6 on 3x plus 4 on 3. And simplifying the x coefficient, I get y equals minus 2x plus 4/3. So these are both exactly the same straight line, just written in different forms. However, this form is useful because I can read the gradient of the equation straight from the expression.